The elapsed time t between the occurrence and the reporting of an accident has a PDF f of t. Given t equals t, the elapsed time between the reporting of accident and payment is uniform on 2 plus t to 10. Calculate the probability that the elapsed time between the occurrence of accident and payment is less than 4. So the first time which we are given, that's a t, that is the time between occurring of an accident and reporting. And then the second time, let's call that as y, is the time between the reporting of accident and the payment. They don't give a symbol for that. We'll call it y. This is the time between reporting and payment. And we have to find the probability, the elapsed time between occurrence and payment is less than 4. So that will be t plus y, because t is between occurrence and reporting, and y is between reporting and payment. So between occurrence and payment, it's going to be the sum of the two times, and we want the probability that t plus y is less than 4. So in order to do that, we need the joint PDF of t and y. And for that, we have to, we already have the PDF of t. So the PDF of y given t is uniform because they say PDF of the second time, which we're calling as y, given t, that's uniform on 2 plus t to 10. So that'd be 1 over 10 minus 2 plus t is equal to 1 over 8 minus t between y between 2 plus t and 10. And then we know that the joint PDF of t and y can be written as f of t times g of y given t. That's how we can find any joint PDF. You do the PDF of the first variable and then times the PDF of the second variable given the first variable. That's a universal formula. And f of ty was given to be 8t minus, f of t was given to be 8t minus t squared over 72. And the g of y given t we found out to be 1 over 8 minus t. And here we can factor out t, and we're left with 8 minus t, which cancels with this one. So eventually it's just t by 72. And the bounds on t, they gave us to be, the bounds on f of t, they gave us to be between t between 0 and 6. And on the g, they gave between 2 plus t and 10 because they told us that it's uniform on 2 plus t and 10. And we were calling it as y. So these will be the combined bounds. And now we have the joint PDF. So the next step is to see the area. Now, at first sight, you may think that, yeah, the area is y between 2 plus t and 10 and t between 0 and 6. Yes, but that is the total area for the whole PDF. We want the probability t plus y is less than 4, so we need to figure this into the equation as well. So now let's see what's going on with the total area. So we have t along the horizontal and y along the vertical. And y was given to be between t plus 2 and 10. Y equals t plus 2 is this line, which has y-intercept at 2 and slope as 1. And y equals 10 will be somewhere above. So it looks like as if I have made a mistake here, but I haven't. This is y equals 8 because we also have t between 0 and 6. And when t is 6, and you put t equals 6 in this equation, you do get y equals 8. So it's being cut off by y equals 8. If we didn't have the t between 0 and 6, then it would be a higher triangle where this top line will be y equals 10. But because of t equals 6, it's cut off at y equals 8. So this big triangle here is the total region for the PDF, for the joint PDF. And when we draw the line t plus y is equal to 4, that's this line where both intercepts are 4. And therefore, the total, so when you do t plus y less than 4, it's the region below this line. But this region is not part of the whole PDF. Only this triangle is part of the whole PDF. So the part that is below this line and it's also a part of the main region is this triangle. And now we need to figure the bounds when we do the double integral. So this is the line y equals t plus 2. So the lower end of this vertical strip is at t plus 2. Y equals t plus 2. And the upper end is at this line where y will be t minus 4. So that's why when we do the region, so basically the probability, maybe we should not even write this step here because we are going less than 4. So this is what we have. Okay. All right. So probability t plus y is less than 4. So as we said, y is between t plus 2 and 4 minus t, and you are double integrating the joint PDF, which we found to be t over 72. And t will be from 0 up to this point. And this point can be figured out by looking at the intersection of this line t plus 2 and this line y plus t equals 4. So basically you substitute the y equals t plus 2 in this one. So you get t plus 2 plus t equals 4, and that gives t equals 1. So this point is t equals 1. So t goes from 0 to 1. And y, as we already said, goes from this is t plus 2. And this is 4 minus t, because that's this line. So t plus 2 to 4 minus t for y, and 0 to 1 for t, and the double integral of the PDF, the joint PDF. And we can pull out the 1 over 72, and t is also a constant. When you integrate with respect to y, you just get a y, so ty, and y goes from t plus 2 to 4 minus t. And then you substitute the t plus 2 and 4 minus t for the y, upper and lower limits. And this one simplifies to t times 2 minus 2t, and then you multiply the t inside before integrating. And now the integral of this is t squared minus 2t cubed by 3. And when you put in the limits, we end up with 0.005. That was choice A.